Part A asks us to sketch this cubic function. And the thing to recognize here is that you've been given this function in factorized form. So it's the product of these three linear factors. And that's actually a bit of a clue. Now, clearly you could expand all those brackets, but there's nothing to be gained from that, and it would take you quite a long time. So it's actually a bit of a clue there to help you out. But first, let's just have a little look at cubics. A useful thing to remember on the whole is if you have a positive coefficient of x cubed, then your cubic will generally look like this, with going from bottom left to top right, with a local maximum first and then a local minimum afterwards. If you have a negative coefficient of x cubed, then the opposite will be true. Now in this case, because I've got a positive x there, a negative x there, and a positive x there, I know I'm going to have a negative x cubed, a negative coefficient of x cubed. So it's going to look like this, and that's a helpful starting point. Now, the clue here that we have is that your factorized form allows you to consider what happens when y equals 0. So when y equals 0, you can substitute 0 for y there. You're looking for the x-intercepts. And because this has been factorized, that really helps, because if I've got three things multiplied by each other equal to 0, I know that one of them must be 0. So x plus 1 is 0, or 3 minus x is 0, or x plus 3 is 0, and that gives me three solutions for x. And that's in fact 3 points that I know are going to go on our graph. So I can see that the graph will cross the x-axis there and there and there. So I'm already beginning to sense what my cubic is going to look like, coming down from there, underneath, coming back up through there, and then over and down through there. So the only point I'm missing now is the y-intercept, and that's what happens when x is equal to 0. So if I now consider what happens when x equals to 0, then I substitute x equals 0 into this equation, and I end up with y equals 9. And that gives me my fourth point. And for a sketch, that's all I need. Please remember that a sketch is expected on straight lines. It just doesn't have to be to scale. So now I have my completed sketch of this cubic function with the 3 x-intercepts and the 1 y-intercept.